is I use expression. It says use x plus a little bit more. So I wrote in t plus delta t. Everywhere there's a t in the expression. If there's a t, if there was just a t, I wouldn't square it. I just have it there. Okay, does that make sense so far? Okay, moving forward. Now, the whole point is to simplify. Ms. Pinto, how can I simplify this expression? Cancel out these two things, right? Cancel out the 2's. All right. Can I factor out anything top and bottom, Ms. Pinto?
No. Yeah.
Yes. What can I cancel out? Delta t. I can take it out of everything. Limit as delta t approaches 0 of 2t plus delta t. And then delta t cancels out with the bottom, right? Everybody see that step?
Yes.
Okay. Now, the moment I cancel out the common factor, what do I immediately follow that with? I'm going to plug in my value. So delta t is 0, so I'm going to plug it in, and I get 2t. What? My slope for any value of x is equal, so any value of t is equal to 2t. So Mr. Resendez, what would my slope be when t is equal to 0? 0, because I plug a 0 and I get 0 slope. Isn't that what we got when we did 0? Hey, does this work for all values? This works for the whole curve. You guys are jumping ahead and said, can we do it for the whole curve? Yes, you can do it for the This is it for the whole curve. Which means at 2 we should get what? 4. So the slope at 2 should be 4. Can we check to see if that actually works?
What are you drawing when you say the slope?
I'm just drawing an M because you were told that slope is M. I'm going to change that out in about 2 seconds.
Okay.
But you're supposed to know slope is M, right?
Y equals mx plus b.
Yes. So, point stepped on. Are you guys with me? Back to step. So what you should be able to do is we're going to go ahead and take the slope at 2, that expression. What should we get if this is right? 4. Let's see if we get 4. Do it. Don't know me. Because we know what this thing has value to us. It is what the whole point was, we talked about why rates are important. Now we have a way to calculate the rate. Exactly, mathematically, and be precisely what it has to be. Okay? So, it's ugly. We'll admit it. It's ugly, but we now have a way to calculate the slope exactly for any value. No more guessing, no more bring your fingers closer together, no more points of secants. Okay? We have exact value now. So, we want notation for exact value. So, the derivative can be written like this. This means the derivative. This also in math land means the derivative. Okay?
What is the notation to show we're going to take the derivative?
No, that's the notation that you have a derivative. So what is the notation that we've taken the derivative? So this is the bottom one, sorry. This is the bottom one.
Gosh.
The notation for taking a derivative looks like this. d dx. Right? This means take the derivative of what follows. Tell me how the function, what does a d stand for in chemistry? What does a d stand for? Or a delta, a triangle. What does that stand for in chemistry? Change it. What is the change in this over the change in x? That's what the notation means. Of course, it was a British and a French fellow that were writing the notation, so they didn't use deltas anymore. They used these. Fair enough? Everybody good so far?
Yes.
Now let's go and do a little pain and suffering. Let's flip this over. I don't want to start with number 11. I want to start with intent instead. Oh, you guys are man enough. Let's do let's do 15, which is 3 plus 5/3 x. Let's do that one first. I want you to find the derivative. Then I want you to find the slopes at x equals 0 and x equals 2. Find the derivative, then find the slope as x equals 0 and x equals 2. Yes, because we're always go. I'm going to write h prime of x because I'm finding the derivative. Is the limit as delta x approaches 0 of 3 plus 5/3 x plus delta x. I'm doing that because that's what we do. Replace the x with x plus delta x. Minus, parentheses, 3 plus 5/3, not replacing the x. Right? All over delta x. That should have been step 1. Okay? We're on the next line. Limit as delta x approaches 0. I've got 3 plus 5/3 x plus 5/3 delta x minus 3 minus 5/3 x all over delta x, right? Simplifying using good algebra 1 skills. Except they never had delta x back then. This is calculus. Mr. Resendez, you see anything that can simplify? What would I do? 5/3x. I like that. Get rid of that one. 3 and -3, right? All right, that leaves me h prime of x is equal to the limit as delta x approaches 0 of 5/3 delta x over delta x. Can I cancel out any like terms? What can I cancel out? Delta x. So then I'm immediately plugging 0 everywhere I see delta x. There's no delta x's. So what's my answer? 5/3.
Why is it always 0? I don't get why it's always approaching 0.
Because delta x is the little bit more, right? What did we do in every single expression? We try to get a better answer.
Yeah, but it wasn't always 0. We that one got closer to 2.
Okay, but listen. 2 is x. The 0.1 is the delta x. The 0.01 is the delta
That's
x.
delta x.
That's why we're writing x plus the little bit more.
Oh, I get
Delta
it.
x is the little bit more, right? We're plugging in x plus some small thing we're adding on.
Okay, I get it.
And we want to shrink that down to 0 to find what the actual answer is. So the delta x is, this is 2, that's x, plus 1. Plus 0.1 is the delta x. Or 0.01 is the delta x. And we shrink it down until we get it down to where it's darn close to 0. We can find what the answer is. So that's what we're doing. The delta x isn't the 2, it's the thing we're adding on.
I get it.
And then we're shrinking it to 0.
I get it.
So x, that would be 2 in this expression. This is the 0.1 or the 0.01 or the 0.001 or the 0.001, what thing we're shrinking down. That's what delta x is.
You're not always shrinking.
Yes, we are, because we're always trying to get closer and closer to the point so we can find the value. We're always shrinking the delta x.
But what if you chose 1.9?
Then this would be 2 minus 0.1. And then this would be 2 minus 0.01. 2 minus 0.001. You can do it that way too. Well, it says plus, but you're picking a negative number. You're picking negative numbers that are closer and closer. You're still shrinking 0, you're just shrinking it from the other side. Right? The value should be shrinking. Yes. All right. Try number 17 to see if you have any algebra 2 skills.
Why?
And once we get 17 done, then I can release you and you can do all sorts of these problems. Oh, crap. Ugh.